In this video, we will solve the question is asked in UGC Net Economics paper of June 2024. This is the second part of this series. The question is, a monopolist produces two goods, X and Y. The demand function for each good is given as is. That is the inverse demand function for good X is being given as is. That is P subscript X, that is price of X, which is equal to 36 minus 3X, and price of Y is equal to 56 minus 4y. These are the two inverse demand functions for the two goods. We have to find out the maximum revenue here. Okay, so what will we do? We need to find out the total revenue function first. So let us write what will be the total revenue for the monopolist. It will be equal to price of good X times units of good X produced, plus for the second good, that will be the price of good Y times units of good Y produced. Okay, this will give us the total revenue first. That implies total revenue will be equal to, so Px is this function 36 minus 3x, to this we multiply by x, plus Py is this very function 56 minus 4y, to this we multiply by y. So what will be the total revenue? Total revenue will be equal to, multiplying this x to each of these terms, it becomes 36x minus 3x square. Similarly, we have 56 times y, 56 times y minus 4y square. This is our total revenue function, and we are supposed to find out the maximum revenue. So how do we calculate the maximum total revenue, since we have the two variables here? Okay, so let me write in place of total revenue is a function of two goods, and let me write it like this. So let's write total revenue is a function of two goods, that is f of xy, which is equal to 36x minus 3x square plus 56y minus 4y square. Okay, now to find out the maximum revenue, we need to find out actually the relative maxima. Okay, so this question is actually related to maxima and minima. How do we find out the relative maxima or minima? First thing is, we take the first derivative of this function partially with respect to x and y. Okay, that is the f subscript x means the partial derivative of this function with respect to x. That means, and we set it equal to 0 to find out the critical points. I will explain it. So we take f subscript x, that is the partial derivative of this function with respect to x. The derivative of x in the first term is 1, so we are left with 36, minus derivative of x square in the second term is 2x, so 2 3s are 6x. We set it equal to 0. We are taking partials with respect to x, so the derivative of the last two terms will be equal to 0, because we are taking partials with respect to x. Okay, now let us solve this. It implies 6x is equal to 36. Dividing both sides by x, we will get, dividing both sides by 6, we will get x will be equal to 6. This is our one critical point. So first thing is, we need to find out the critical points. Similarly, we take the second partial, that is f subscript y, that is the partial derivative of this derivative total revenue function with respect to y. So derivative of y in the third term is 1, we are left with 56, minus derivative of y square is 2y, so 2 4s are 8y, and we set it equal to 0, implies 8y is equal to 56, implies dividing both sides by 8, so y will be equal to 7 or 7. So we got the two critical points. Second is, we need to check for the relative maxima. So we are also we need to calculate the second partial, that is second direct partial, second order direct partial, that is f xx, that is the second derivative of this function with respect to x. F subscript xx means the second partial derivative with respect to x. So the derivative of a constant is 0, derivative of x is 1, so we are left with minus 6. Similarly, we find the second direct order direct partials with respect to y, f y y, that is the derivative of this function with respect to y. So derivative of a constant is 0, derivative of y is 1, so we are left with minus 8. Okay, we also need to find out the second order cross partials, that is f of xy. That means the derivative of this function with respect to y. Since we have no y in this, the derivative of 36 is 1, derivative of 6x will be also equal to 0. Sorry, the derivative of 36 is 0, derivative of this term is also equal to 0, because we are taking the partial, second partial with respect to y. So it will be equal to 0. Okay, and similarly we need to find out f of yx. So the derivative of this function again with respect to x, so since no x is involved, its derivative is 0. Now what are the conditions for maxima? So conditions for relative maximum, we need to find out whether these conditions are satisfied or not. Okay, so we find out the critical points, we need to check whether they are actually at the relative maximum. So first condition is that, and let me be specific here, for relative maxima, so first derivative should be equal to 0, f subscript x, we set it equal to 0, f subscript y, we set it equal to 0. I am explaining. Now second partial is, that is f xx, for relative maxima it should be less than 0, that is f yy, it also should be less than 0. And third condition is the product of second order direct partials, that is f xx times f y, it should be greater than f of xy times f of yx. Okay, here we can see second partial both are less than 0. Okay, these are negative. This condition is fulfilled. This we calculated, the critical point is 6 and 7, and this condition is also fulfilled, that is fxx, that came out to be minus 6, times fyy, it came out to be minus 8, and fxy and fyx, it is 0 into 0. Here you can see 8 6 are 48. I guess it is 48, and here it is greater than 0, so all the conditions are fulfilled here. Actually we didn't need to go further here, so I was just trying to explain how do we calculate the maximum here. So for maximum, we set the first derivative is equal to 0, find out the second order direct partials if they are less than 0, and this condition, then we say the given critical points are actually the points of relative maximum. Okay, so here all the conditions are fulfilled, that means these are the our critical points which satisfy the relative maximum principle here. Now to find out the total revenue, now you can simply plug the value of x is equal to 6 and y is equal to 7 into the total revenue function in this equation. Okay, so let us do that very thing if I have the space left. So in this equation we plug, so total revenue will be equal to, we have 36 into the value of x, we got 6, then we have minus 3 x square minus 6 square, which is 36, then we have plus 56, the value of y is 7, plus then we have minus 4 y square minus 7 square, which is 49. We need to solve this again. So total revenue will be equal to 6 6 are 36, 6 3 are 18 arda kunuvu ako. So this is 216 minus 3 6 are 18, 3 3 are 9 tageda, plus we have 7 6 are 42, 7 5 are 35, 36 37 38 39. So we get 392 minus here 4 9s are 36, 4 4 are 16, 17 18 19, so 196. Let us find out the total revenue now. Total revenue will be equal to, so this is the positive term, this is the positive term, let's add them. Now tage the that is response here. So 6 or 8 minus, these are the negative terms, we can add them up. So 8 plus 6 is 8. So the 9 now the then we have 1 plus 1 plus 1, which is 2. So total revenue will be equal to 8 minus 4 is 4, 0 go 0, Shan is it. Let me see if I have done it correctly or not. 6 minus, so we have 196, so it is here 304. Okay, so because 8 plus 6 is 14, then we have 9 plus 0 is 0, then we have 1 of the carry, so it becomes 10. 1 is carried, so we have 1 plus 1, which is 2, and the carry 1, that is 3. So it is equal to 6 minus 3, which is equal to 3. So the total revenue will be equal to, maximum total revenue will be equal to 304. So the correct option should be this option.